Hello everyone, welcome back to my channel. In this video, we're going to talk about printing prime numbers from 2 to 100 and also printing alternative prime numbers from 2 to 100, right? So in our previous video, we have seen what is prime number and how it can be, identified that a given number is prime number or not. Okay, if you still have questions about prime numbers, you can go back to my video to check a given number is prime number or not, where I have explained in detail about how a prime number program can be achieved, right? In this video, we're going to talk about how to print prime numbers from 2 to 100. And also, in my previous video, I have mentioned two ways of writing a prime number program. And today we're going to talk about one more way of writing it and also getting into printing prime numbers from 2 to 100 and also getting into printing alternative prime numbers from 2 to 100, right? So let us get into. So let us assume that we wanted to know, the factors of 15. Okay, so let us assume that 15 is a number where we wanted to find the factors of 15. Okay, so to find the factors, we're gonna start with this way, like 15 mod 1, 15 mod 2, 15 mod 3, 4, till it reaches 15. And wherever we find that there are, somewhere where the modulus operator is equals to 0, then we can say that these are all four factors. The factors are 1, and we have 3, 5, and 15, right? So these are the factors for 15. If we clearly observe this, what what is the thing that you can observe here is, see, after 7, okay, after 7, from 8 to 15, from 8 to 15, the only factor that which we could see is 15 itself, and we don't see any other factors, right? So the only factor which we could see is 15 itself, but not any other numbers from 8 to 14, which means 15 divided by 2. What is 15 divided by 2? It is 17. So we no need to iterate after divided by 2. Like, you don't need to iterate from here to end of the, number. Indeed, what we can do is we can iterate up to 15 divided by 2 and find is there any other factor or not. If it has any factor, then we can say that it is not a prime number, right? So that's what we have discussed in our previous video, right? Okay, so going back, this is the logic which we have written in our previous session, where it starts with integer I equals to 2 and it ends at with I less than number, because we are not finding the factors, we are not finding the how many factors it has. Indeed, what we did is, in between, from 2 to the number, is there any factor that is present for this number? In that case, we can say that it is not a prime number. So that's what we did, right? So what we gonna do here is, we just gonna, in the iteration, we're gonna reduce the iteration from number to number divided by 2. Okay, so from number to number divided by 2. So it is equals to number divided by 2. So if I save this and try to execute this code, you could see that it is 21 is not a prime number. Let us change the same thing to, we can find 17. Okay, 17 is a prime number. Let us see whether it is coming or not. 17 is a prime number. So which means the logic works if we use number divided by 2 as well, right? So with this, we have written three different ways of writing the logic for prime number using for loop, right? So next one is, we're gonna get into how to print prime numbers from 2 to 100, right? So now for this, right, if you could see this clearly, if we see this, we need to print prime numbers from 2 to 100. Okay, so we need to find factors for 2 and where it has started, where it has ended. So that is the major thing which we have been explaining during from the starting of the for loop, right? So it has to start from 2 and it has to end for 100, end at 100, right? So now we need to find the factor for 2. First, we need to find the factors for 2, and for 2, again, it has to start from 2 modulus 1, 2 modulus 2, like that. So this is for, we need to find each time this 2 is a prime number or not, and then go for the next number, find that is a prime number or not, and go for the next number, and then check whether it is a prime number or not. So that's how it goes, right? So we need to find factors for 3 and check factors, and if it has a factors between 2 and 3, then we say that it is not a prime number. If it has a factor, it is not a prime number. If it doesn't have a factor, then we can say it's as a prime number, right? So same is for 4, 5, it goes on till 100. So we know that it starts from 2 and it ends at 100. And we know, for this, right, in order to check whether 2 is a prime number or not, so that we have already written a logic, right? On top of this logic, again, we need to write, we need to pass numbers from, from in this loop to this prime number logic, right? So let us go back and see how it can be achieved through programming. Okay, so if you could see, this is how we gonna do it for each time. So this logic works for this 2. It will be replaced with 2. 15 can be replaced with 2, and then 3 can be replaced with 15, and then 15 can be replaced with 14. It goes on like this. So this is how printing a prime numbers from 2 to 100 will work, right? So it is nested for loop which we need to use. Okay, so let us go back. I'm gonna copy the same code. I'm gonna write a new program, that is print prime numbers from 1 to 100. Okay, public static void main, click on finish, and I'm taking this into separate window, and I'm copying this from I equals to 2 to this one. My bad. Copy this and then paste it. So now I have, taken a prime number logic which works for, which worked earlier, right? So for, let us say that integer factor which we have used, okay, and then we're gonna start with the integer number equals to, we start with 2 because print prime numbers from 2 to 100. 1 to 100, 1 is not neither a prime number nor a composite number, which we have discussed, right? So we start with 2, and then number less than or equals to 100, number plus plus, right? So it starts with number, and then number 2, and then it ends up with 100, right? So here in this, since it is only one time, we have used factor equals to 1, right? For every number, we need to, find the factor. It has to be, if it is 0, then it is a prime number. If it is not, then it is not a prime number, right? So which means I'm going to do like factor equals to 0 every time it enters inside the prime number logic. This is my prime number logic, right? So here we are not gonna print whether the number is prime number or not. Indeed, what we are doing is we need to print whether, from 2 to 100, what are the prime numbers that are available, right? So in that case, here, if factor equals to 0, which means it is not getting inside this if statement, which means for the number which it is coming, like, for the first time 2 will go inside, and second time 3, iterate after the increment 3, and then 4, 5, 6, and it will go on till 100, right? So for the first time, if it goes inside for number 2, okay, if it is not going inside, which means it does not have a factor. If it does not have a factor, means what happens there, it's a prime number. Say, let us assume that we can take 10. Okay, so after getting inside, I equals to 2, okay, 10 modulus 2, which is equals to 0. 2 is a factor for 10. So as soon as it goes inside, number mod I is equals to 0. As soon as it goes inside, factor equals to 1, and then break. So break will come out of this loop, inner loop, not this loop. Break will come out of this internal for loop. Okay, so in that case, after coming out of this, if factor equals to 0 means then it is a prime number, else it is not a. You don't need to print whether it's not a prime number or not. I mean, else statement. We just need to print whether, the prime numbers from 2 to 100, right? Makes sense, right? So now number is a prime number. If it is equals to 0, number is a prime number. I'm removing this else statement and let us execute this piece of code. It's very simple. Just if you know the prime number logic, all you need to do is we need to pass this number every time. So that is the only thing which we need to do. And every time this factor value has to be given as 0, because as soon as it gets inside this for loop, it has to see whether the factor value is 1 or 0 after coming out of this for loop, right? So I'm executing this piece of code, right click and run as Java application. And we could see that 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 11, 13, 17, 19, 23, 29, 31. All are prime numbers which we have printed from 2 to 100. Okay. So in this case, we have printed prime numbers from 2 to 100. We didn't change anything. All we did is we added one more for loop in nested for loop where it starts from 2 and ended at 100. And what happened? We are passing this number to this internal for loop. Okay. After coming out of this for loop, if factor equals to 0 means, which means if initially the factor value is 0, after coming out of this for loop, if factor value is still 0, which means there is no factors that are available between 2 and number. So that's where it is a prime number, right? So this is printing prime numbers from 2 to 100. Don't get confused. We need to use 2 for loops over there rather than using only 1 for loop. 1 for loop is for to checking a given number is prime number or not. But the next number, if you want to check, then again you need to give one more for loop where it will be passed one number each time to the inner for loop where it will check that number is a prime number or not, right? Makes sense? So this is printing prime numbers from 2 to 100. Let us see one more question which would be asked, to check how good you are at writing the logic. So printing alternative prime numbers from 2 to 100, right? So we need to print alternative prime numbers from 2 to 100. Okay, so let us assume that if you want to print prime numbers from 2 to 100, this is how it goes: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and it goes on, right? But if you say alternative prime number, it has to print. If it prints 2, then it starts from 3. If it should not miss, I missed 2 first, and then it printed 3, and then okay, so it printed 3, 7, 11, not 11, but 13. And then it should not print 17, it should print 17, 19. It should not print 23, it has to print 29. Okay, so if it is, one way. And the second way is, again, the next way is like 2, printing like either 2, and then it should not print 3, it has to print 5. It should not print 7, it has to print 11. Okay, so alternative means it can either start from 2 or it can either start from 3. Okay, so how we can achieve this, right? So for this, we're gonna use one more logic which we have explained in our previous session to check a given number is odd or even. Okay, so you print this 2, 2, 3, 5. This is what we have done in our previous in this printing prime numbers from 2 to 100, right? So after printing this, what you're gonna do during printing that, this is where you're gonna print the number, whether number is prime number or not, right? So during printing, what you need to do is we just need to check whether the number is odd or even, which means you print only the odd numbers or you print only the even numbers, right? Makes sense, right? So you print only odd numbers, that is 1, 3, 5, 7, 9, 11, 13 goes on. Or either that way, or you can print odd numbers, even numbers, that is 2, 4, 6, 8, 10, 12, 14, go on, right? So what we can do every time whenever it prints it, right? Every time when it prints it, we just need to, you know, check that number is odd or even, right? So how we can check during printing only you need to do. It's not like before the thing, right? So I'm gonna write one more program, one more class, create alternative prime number from 2 to 100, right? So I will finish it off and then push this here. I don't want this prime number program because it's already there. So I'm going to copy this entire code and then paste it over here, right? So all I need to do is I just need to print alternative prime numbers, which this else statement is not required, right? However, what I'm gonna do is I'm gonna give something called count equals to 0. Okay, so every time while printing it, it will first, if count mod 2 equals to 0, then you print it count plus plus. Okay, so which means every time we are actually taken another variable where you're gonna check a given number is odd or even. During you need to print the alternative, right? We need to print the alternative means some number has to be increasing, right? 1, 2, 3, 4, 5. We need to give this numbering as well, right? Every time it prints, the count value will get incremented, and then it will check whether the number is odd or even. So now it is printing even numbers. Okay, and then next time if you give count modulus 2 equals to 1, then it will print odd numbers, right? Let me run this piece of code and see whether it is giving the correct output or not. So first one is, as I said, it is giving even number starting from 2, 5, 11, not odd number. Sorry, my bad. Sorry, it's not even number, it's odd number. So starting from 1, that is, if you consider output, if you consider output, you could see it printed 2, which is 1, 5. I mean, the second number is 5, which is present in third place, and then 11, which is present in fifth place, and then 17, which is present in seventh, and then 23, which is present in ninth place. It goes on, right? So it has to be, the output has to be 2, 5, 11, 17, 23, 31, 41, 47. It goes on, right? So if I give equals to 1, if it is giving equals to 1, then let's see what would be the output. So now it started with 3, 7, 13, 19, 29, 30, 37, 43, 53, 61, and goes on, right? So what happens in case if this count plus plus is kept inside this if statement? Right? There may be chances that people will get confused and they'll keep it inside this if statement, count mod 2 equals to 1, and then they will try to execute it. So what happens now? It did not print anything. However, if I keep this as count modulus 2 equals to 0, then if I try to execute this, it printed only 2 is a prime number. It did not went for the other numbers because every time it iterates, right? Every time it prints it, the count value, for the first time it is 0, which is 0 modulus 2 is 0. That's where it has been given, that number has been printed, right? If you consider any other number, because count value is 1, 1 modulus 2 is equals to 0, which is not, right? 1 modulus 2 value is 1, which it won't get inside this if condition and it won't get printed. Okay, so that's where whenever the factor equals during printing, if the factor equals to 0, then we need to put it inside this if statement. Okay, so this can be, this would be very simple one, and this can be rewritten, while using the functions as well. That would be really interesting one if we use the functions. Okay, So there are again 4 types which we will discuss, and in addition to that, there is one more type called recursive function, which is most important concept which will be used, which we're gonna discuss in our upcoming sessions, right? So that's it for now. We're gonna talk about how this can be achieved using while loop. All these programs, whatever programs for loops which we have used, this everything can be achieved through while loop as well. Okay, so we're gonna see that as well in our upcoming sessions. There are few more videos, few more programs which we need to know. That is printing the patterns like pyramid, and then few other patterns which would be asked in the interview where you'll get confused, and also reversing of the number, sum of the digits, and few other programs which would be asked and where you will get confused, right? So we're gonna talk about that as well. We're gonna, I'm gonna do a video for the same, right? So still getting confused with writing the logics, let me know a program which is making you confused in the comment section. I'll make a video for the same. Thank you very much for watching. Happy learning, and let me know your feedback in the comment section. Please subscribe to my channel and share to your friends. Thank you very much. Happy learning.